Congratulations on making it through Chapter 3. In Chapter 3, you learned a lot about quadratics, meaning just functions that are x squared, right? So we learned all different sorts of ways to solve them. All of our functions had some sort of variation of x squared in it. Well, what a polynomial is that you're going to find is, and through the course of the chapter, we're going to figure out how to graph things that might start with x to the fourth or x to the fifth and the differences they might have. Okay, so I'm sure you can get a couple of guesses. With x squared, we had two roots or zeros or solutions. So what would you think in x to the fourth or x to the fifth? I hope you're thinking about 4 roots or about 5 roots. Now it doesn't always have to be 4 or 5, but that's the maximum. So a fourth root actually looks something like this, where you could have 1, 2, 3, 4. So basically what we're doing is we're stepping it up a little bit, and we're talking about things that can happen with these higher level polynomials. So we're going to start with some vocabulary words first. The first one being polynomial. And this is on page 78 in your notes. We discussed before that, and maybe we didn't, but a monomial is just one term. So it has a number and a variable or the product of them. So it could be something like 4x squared. That would be a monomial. 5y. Anything like that, or a product of one or more variables. So actually, JEF is also a monomial. So what makes it a polynomial then? A polynomial is a monomial or a sum of monomials. So if I took all of these I just wrote and I put plus or minus in between them, this now is considered a polynomial. Okay? A polynomial function is something that's labeled first of all as a function, and then these a sub n's, and a sub n minus 1, they are the exponents are the coefficients. Those are what you call coefficients, and so those numbers just have to be real numbers. So they could be positives, negatives, they could be fractions. They just have to be a real number. That means non-imaginary. And then the exponents, which is talking about here, are the x to the n and minus 1. And this is just the way the definition looks. This one would be like x to the 0. This is like x to the 1, x to the 0. So what happens here is all of these exponents have to be whole numbers. That means they have to be numbers larger than 0. So they have to be 1 or more. Okay. The leading coefficient is the first one, the one that's in blue here. That's called your leading coefficient. N is called the degree. Now notice the degree has to be first. It would be the largest exponent inside the polynomial. So sometimes they like to play tricks on you and move those around, but that should be the first or the highest exponent is called your degree. And then a sub 0 is called the constant term. So the constant term is the one that does not have a variable on it. Okay, and a polynomial is in standard form when its terms are written in descending order from left to right. So that'll be one of the first things you learn how to do. All right, so a couple of words you need to know, and I think you know most of these, like these are what the polynomials are called. So a constant would be just a number. So like if I said, oh, actually here's an example. F of x is negative 14. That is a constant function. A linear function, which you should already be familiar with, would look like something that has a degree of 1. If you notice here it says degree of 1 because my largest exponent is 1. Quadratic you are very familiar with. And that is where you're going to look for this x squared. Notice how it is in descending order, which is how we want to write our polynomial functions. So the ones that are going to be new to us are going to be the cubic and the quartic. And in this section, we won't get too, we might do an 8 to the 5th, but I won't, or an x to the 5th. I just won't ask you to do anything but graph it. You wouldn't have to label it. So you would call this a cubic because it has a degree of 3. The largest exponent is 3. And here's an example of what that would look like. So just kind of take that in for a minute. And then the quartic, of course, is when your degree is 4. And you don't have to, just so you know, just like it shows here in the example, it has to, the largest has to be 4, but it doesn't have to have an a to the third like this one does. It doesn't have to have an a squared. It's just that the largest one is x to the 4th. Now for a few examples, this asks us to do several things. It says, first of all, decide whether it's a function or not. Then if so, write it in standard form, state the degree, the type, and the leading coefficient. So number 3, I would say, because I see all of these coefficients are real numbers, and my exponents, this one has a 1, my exponents are all whole numbers, then I would say yes, this is a function. So we'd say yes for that part. Now it says write it in standard form. Standard form means the largest needs to go first. So this one would be the first one. And then we'd go descending order from there. So my negative 6x squared, notice how my signs for the coefficients stay the same. And then this one would be minus 3x and then plus 2. So that takes care of my standard form for that question. Its degree then, and since I can look at it easily and see it, the degree in this case is going to be 3. Its type is going to be a cubic. And the leading coefficient is 5. Leading coefficient is the coefficient that goes with your largest term. Okay, so for number 4, let's see, we're going to check out all of our coefficients first. They are all real numbers. My exponents are all whole numbers. So it looks like this one is yes, also a polynomial function. We just need to rewrite it correctly. So let's see, 6x to the 4th is going to be my first term. And then I'm going to do minus 4x to the 3rd. Then I'm going to do plus 1/2 x squared, and then plus 3x minus 1. Okay, so now the degree in this case is going to be 4. This will be a quartic, and what was the other thing? That's the type, and the leading coefficient is 6. All right, now in number 5, let's check out all of our coefficients. Yep, they are all real numbers. I have a 4, 3, negative 2, and 1. So that negative 2 is the questionable part. Now we said back in our definition, we said that the exponents had to be whole numbers. Whole numbers are numbers larger than 0. So on the number line, that's a terrible color, it would be numbers like 1, 2, 3, 4, nothing in the middle, and only positives. Therefore, we would say that this is not a function. This is something you're going to have to work on memorizing, which is knowing the end behavior. So first of all, what do I mean by the end behavior? The end behavior tells me what happens at the ends during the positive infinity. So if you look here, here's the positive infinity or the negative infinity part of the graph. It's because the cool thing about polynomials is that they're always smooth, fluid graphs. And on the ends, you'll always have arrows. So we're trying to build enough tools to be able to graph correctly. So the first thing you have to know is what's happening with these arrows. And so I'm going to give you the way that I memorize them, and then you can come up with your own patterns. So the way that I do this is I break them off into even and odd. Okay, so what do I mean by even? If the degree of the function is even, for instance, let's just take something we already know, like let's just do 2x squared. The degree is even in this case, and we already know that that's a parabola facing up. So what this tells me is that when this degree is even, and the leading coefficient is positive, so the 2 is positive, that you're going to open up and up on each ends. So the way I'll ask you to do this in the book, you'll give me up, up, okay, when you do examples. So for when it's even, but that first number is negative, we already know, so we can do this without even knowing this rule. When we had x squareds, that was a facing down parabola. So we already know that it's going to be down, down, and because this coefficient, the leading coefficient, is negative. So the way you would show that is down, down. Now what happens in the middle here is what comes throughout this chapter. We're going to piece it all together as we go, and eventually you'll be able to graph the whole thing, but we have to start with the end behaviors. All right, so that's how you're going to remember when it's even. Now when it's odd, so group these together if you will. So when that degree is odd, for instance, a cubic function, x to the third, and let's put a 2 out in front. So when the degree is odd and the leading coefficient is positive, first of all, odd tells me it's going to be opposite. That's how I like to remember. Odd equals opposite. So one's going to be up, one's going to be down. This positive tells you how it's going to end up. So if it's going to end up positive, then it's going to start down because they're opposites. All right, so let that sink in. You may want to listen to that a couple of times. And let's look at the other case. Now this is an odd degree of x cubed, so x to the 5th, x to the 7th, any odd degree. The leading coefficient is negative now, so that means it's going to be opposite, and it's going to land in the negatives. So this side would have to be negative, which means it's going to start positive. And again, that's just something you have to play with, and we'll practice it until you get it memorized. Okay, this is on page 76 in your book, and it has some graphs underneath it. But what I want to do is use what we've just learned about finding the ways for you to try to match them for finding the end behavior. So this degree here is 3, and the leading coefficient is positive. So that tells me it's odd, and it's going to end up in the positives. So you're looking for a graph that does this. Okay, so let's see about B. That's odd and negative. So you're looking for a graph that does this on the ends. Now what happens in the middle is something, again, that we're going to piece together later, but right now you can at least try to match them up by that, and then you can always plug a point in if you need to. Okay, so what's happening in C? This is an even exponent and odd. That means it's going to be the same and both facing down. This one is even and positive, which means it's the same both facing up. This one is odd positive, which means it will be start down and end up. And then this one is even and positive, which again will be up and up. Okay, so you see if you can match them just by knowing that part. Okay, so now we're going to go ahead and move into 4.2 because this is something that you already know. Adding and subtracting polynomials is really just adding like terms. So you're going to start with the largest degree, which will be 5x to the 4th, and I don't see any other exponent there, so that's going to be a part of my solution. And then I'm going to move to the 2x to the 3rd. I don't see another 2x to the 3rd, so I'm going to leave it as 2x to the 3rd. So I'm done with these two. Now my x squares, I have a 3x squared and I have a negative 7, and mind you, I'm adding these two things. So 3 and negative 7, which is negative 4 x squared, and then I can cross those off. I'm done with them. Now I'm going to move to my x's. I have a negative 6 and positive 6, which are going to cancel out and give me 0. And now I have negative 10 and positive 1, which is negative 9. So this would be the addition of these two polynomials. Now subtraction works the same way, except we're so used to addition here in the middle that subtraction can really screw us up. So what I ask all my students to do with subtraction, just to minimize the error, is to distribute this negative and make it an addition problem. So I would just call this, you can do it either way. You can make it like plus and then negative 8x cubed minus 2x squared plus 5x plus 1. And the reason I do that is because it never fails. If we don't distribute that negative now and force ourselves to do it, we'll forget it in the midst of the problem. Okay, so now we can combine things. So we have this 4x to the third and this negative 8x to the third, which would be negative 4x to the third. We have 6x squared and negative 2x squared, which would be positive 4x squared. We have negative 9x and 5x, which is negative 4x. Oh, we've got a lot of 4's in this one. And then 1 and 1 would be 2. So again, that would be the addition of the two. All right, and then finally we have multiplication. Again, this is new to you. I'm just going to remind you. We're going to distribute this negative 2 x to the 4 through to everything. So negative 2 times 10 would be negative 20. And if you forgot the x to the 4th times x to the 3rd, we add exponents. So that would be x to the 7th. Then we have plus 18x to the 6th, plus 14x to the 5th, and minus 8x to the 4th. Okay, and that's just distributing. Now, these types of questions in F2 with the multiplication, you have done multiplication of binomials, something like this, where you distribute. Now you're going to be seeing more trinomials, possibly. So it works the same way. We're going to take this first term and distribute it to these two. So that would be negative 24x to the 3rd, it looks like. And then we'd have plus 16x squared. Then what I like to do is get a different color and take the next term and distribute it. So this would be a positive 9x squared. Now I like to do the stacking method where since I already see the 16x squared, I'm going to put my plus 9x squared on top of it. And then I have negative 3x squared and 6 is negative 6. I'm sorry, negative 3x and 2 is negative 6x. And then the last one, the 1, I'm going to distribute that to negative 3x. So I'm going to stack it with its like term. And then positive 2 here. So now all I have to do is add straight down. So this would be negative 24x to the 3rd plus 25x squared. This would be negative 9x and then plus 2. All right, so you've seen a little bit of everything, and now just get the assignment to practice.